Hi, welcome back to the second video of the lesson on depreciation. The first part of this lesson, we learned about what is depreciation, why it's important, and the simple way or the simple method of calculating mathematically depreciation of an asset, which is the straight line method. And we also introduced the second method, which is the declining balance method. And we ended the first part of of this lesson by raising the issue that we will face when we deal with declining balance method, which is if we have an asset and we are in the book, we want it to end up with this value, the salvage value of 100,000. The formulas we have don't represent or don't include F in them. It's only dependent on the initial value and the rate of the depreciation. And that will create an issue because we will not end up with the book value at the last year to be equal to the salvage value. So of course the double declining balance, 2 over n here, the rate is 0.4. It's a very aggressive depreciation model, and you will end up here with a value of the asset less than what it's supposed to be, equal to the salvage value. So in this part, we'll learn how to deal with these situations here, or this issue of using the declining balance method. So there is no guarantee that declining balance method will provide book value at the end of the last year, Bn, will equal to the salvage value. And this is an issue, and we'll resolve this issue manually. So we'll not depend completely on the formulas we have. We will apply 2 checks. Depending on the problem and what case you will face, will you be ending, if I go back to the slide here, will your last book value here, the last one, will be ending up above the salvage value or below the salvage value. So these represent, or this one represent one case that requires 1 check. And these 2 represent another case, a second case that requires a different check and a different correction that I will apply and enforce on the model. So the first check is switching to straight line, and the second one is stopping the depreciation. So let's see each one. So the first one is we switch to straight line, and this check here, it's literally a check, an inequality check that I apply and see if it's satisfied. To see if I will change my depreciation in the middle of the asset from a declining balance to a straight line. So this check here, I calculate 2 values in every year. So every year, it's not just a matter of applying these 2 formulas of DT and BT. I have to really make sure that I'm not messing up my future book value, and it will not be equal to the salvage value. So the first value I will calculate, which is the regular depreciation charge if I follow the declining balance, which is equal to P times BT minus 1. That's the very basic formula for calculating DT. So the depreciation in a year is equal to the depreciation rate times the book value at the end of the previous year or at the beginning of this year. This is the first value to calculate. The second value to calculate for the comparison and the check here to apply it is the idea that if I decide to switch at this year, the depreciation of this year and the next subsequent year will follow from now on a straight line. And this is basically calculating the amount of depreciation that will happen in this year and future years if I switch to a straight line. So if I switch to a straight line, now my initial value of the asset is equal to BT minus 1. It's the value at the beginning of the current year. And I want to hit F at the end. And I will lose the value between this BT minus 1 and F over how many years? Over N minus T minus 1. So I still have N minus T minus 1. So let's say I'm in the 4th year of a 6-year asset, and I'm trying to figure out, should I switch right now to a straight line? I still didn't figure out the depreciation that's happening in the 4th year, and I still have the 5th year and the 6th year, to go over or go through them. So the 4th year, 5th year, 6th year, 3 years. That's the amount of, that's number of years to apply a straight line. If it's a 4th year, then to match with the formula here, 6 minus 4 minus 1, that will give you 3. Right? So there's a way to understand this, why it's n minus t minus 1, not n minus t only, is that you are including the current year in the depreciation that will happen until the end of the asset, and that will be modeled using a straight line. Right? So now you calculate it each year, these two values, and the idea is you apply this check. And this amount here, I will call it D straight line, DSLN. And I will check that if the D straight line, if I switch to a straight line in this year, everything in the past is done. It's following a declining balance. But in this year, if I decide to switch to a straight line from now to the future or the end of the asset life, and this D straight line, that straight line depreciation provides more depreciation than the declining balance depreciation, that if I decide to follow it and continue with it, in this case you will decide to switch. So you will always follow the model of depreciation that gives you more depreciation than the other one. So typically you will just keep following declining balance from the beginning to some point when, if you switch to a straight line, it will actually give you a higher depreciation or a more depreciation. So this is just an example here, plotting. This is a declining balance. You can see accelerated depreciation in the first years, slowing down a little. And then you can see I'm going, for the salvage value is equal to 0 here, I will not be able, like if you think about it as a trajectory, I will not hit 0. I will have to hit above it. So at some point I have to switch to a straight line to be able to hit my 0 salvage value. And it happens at this point. So this check, I applied it at the first year, it didn't satisfy. Second year didn't satisfy. Third year didn't satisfy, but the 4th year it did satisfy, and then I'm switching to a straight line that will happen in the 4th and the 5th year. So let's see that another example in more detail. So we have here this machine, 500,000 over 5 years, and a salvage value of 100,000 at the end of the 5 years, and we're applying a declining balance with 125% rate of a straight line. So it's called a 125% declining balance method. So to summarize, PFN and P lowercase, the depreciation rate is equal to 1.25 divided by 5. And summarizing here, this is the book value formula that I will use. And I will use this formula here for the declining balance depreciation amount, and this formula here for the depreciation amount if I decide to switch to a straight line. So my goal is to fill this table, figure out the depreciation amount, the book value for every year. And my goal is also end up with the book value at the 5th year, at the end of the 5th year, to be equal to the salvage value of 100,000. So starting with the first year here. So I will calculate first D1, which is following this formula here. The first value of this inequality check is equal to P times BT minus 1. B1 minus 1 is B0. B0 is the initial value of the asset. So I end up with 500 P uppercase, and I will end up with this depreciation amount of 125K. That's D1 if I follow declining balance. If I decide to follow the straight line here, which is not typical to switch to straight line in the first year, but we're doing here the check anyway. So D straight line is equal to BT minus 1, or in the first year it's B0 minus F divided by N minus T minus 1, and T here is equal to 1. So that's basically here. I'm kind of changing my mind completely now and saying let's not do a decline balance and do a straight line over 5 years, losing 500 minus 100K. So this means I'll be losing 80,000 in every year. Now you can see here declining balance is giving you more depreciation, so let's go with it. So use declining balance. My first depreciation, the first year depreciation is 125. And B1, applying this formula here, is equal to 500,000 times 1 minus P to the power T, and T is equal to 1. So I end up with this value. Or another way is just say 500 minus D1, that will be B1. So done with the first year. Second year, similar process, a very systematic process here. D2 is equal to P lowercase times B1, following this formula. So I end up with 93,750. Now applying the depreciation straight line, it's not the same value as before now, because now if I switch to the straight line, I'm depreciating over 4 years, not 5 years. So it's B1, that's the latest book value that I have to start the straight line depreciation if I decide to do so, minus the salvage value over 4 years of depreciation. And that means I'm ending up with 68,750 straight line depreciation, which is less than the declining balance depreciation in the second year. So I will stick to the declining balance. D2 now is confirming it. It's equal to the declining balance D2 value. And B2 is equal to, I can say it's 375 minus 93,750. That will be this value, or apply that formula here. So done with 2 years, 3 more left to go. So the third year, D3 is equal to P times the book value that I have latest here with me. So it's B2. That's the book value. That's the depreciation amount in the third year if I follow the declining balance. If I decide to switch to straight line, I will be depreciating from 250 to 100,000, and I'm doing it over 1, 2, 3 years. 5 minus 2. So now still declining balance is more aggressive here. So I will D3 will be equal to D3 declining balance, and B3 will equal to, apply this formula, or you can say it's 281, 250 minus 70, and that will give you this value here. Done with 3 years. The fourth year, applying the formula for dt. So dt here, d4 is equal to p lowercase times bt minus 1, or b4 minus 1, or b3. That's the declining balance depreciation in the fourth year. If I switch to a straight line, here you go. Straight line now is this is the correction point. Straight line is giving more depreciation than the declining balance. And here you go. Now I will switch to a declining balance, to a straight line. So switch to straight line depreciation. What this means here is my life will become easier from now on. So the depreciation amount in the fourth year would be equal to the latest depreciation of straight line that I have, which also will be equal to the depreciation that will happen in the next year, which is the fifth year. So the book value that I will have now in the fourth year, at the end of the fourth year, would equal to, now I cannot use this formula anymore because I'm disregarding now the book value, the declining balance. Declining balance was useful for the first 3 years, but fourth year and the fifth year I'm switching to the straight line. So the book value at the end of the fourth year would equal to the book value at the end of the third year, which is the beginning of the fourth year, minus whatever depreciation happens during the fourth year, which is the one I just calculated here, the DSLN, and that will be the book value at the end of the fourth year. You see here my depreciation amount, I got it fixed to be that value I figured out from the fourth year straight line switch, which is here. And now the book value of the fifth year at the end of the fifth year is equal to the book value of the fourth year minus D5. And I see here I'm ending up exactly with $100,000 because I had it in the DSL formula that I used in the fourth year. So I'm, bullseye, I'm finishing in the book value B5 here to be equal to 100,000, the salvage value. And this is my goal, is to finish with the book value equal to the salvage value. So to summarize, this is kind of the plotting of the book values of this asset. This is all a declining balance depreciation the first 3 years, and then the correction point happened at the transition between the third and the fourth year. So the fourth and the fifth year, they follow here a straight line declining balance. So all of that is applying one check for one case when, if I follow the declining balance, the book value at the end will be higher than the salvage value. So I will need to correct my trajectory and use a straight line. Now the second check is used for the second case. So here the idea is you will first always calculate using the declining balance, but every year you will check that that the calculated book value is more than the salvage value. Once you go below it, like in this example here, all these values are higher than the salvage value, but if I follow the declining balance, I'm dropping below my salvage value of 20,000, and that cannot be acceptable here. So I will stop my depreciation and I will just correct myself to be like that, which means that in the fifth year there is no depreciation happening. So the value of the asset will just stay 20,000 and nothing will happen, no depreciation or no value loss in the fifth year. So let's revisit the first example, but now make the model of depreciation more aggressive. We're using double declining balance, not the 1.25% declining balance, which means now my P lowercase is equal to 2 over n, or 0.4 depreciation rate. So now let's say I don't know which case I'm dealing with. Like, should I apply case 1 or check 1 or check 2 here? Of course, we're doing this example here following the discussion about check 2, so probably it's a check 2 case. But if you want to know, you have to calculate Bn using the declining balance formula. So it's equal to P uppercase times 1 minus P lowercase to the power T, or T here is equal to n in this case. And I will see this Bn. If I follow the declining balance, what's the case? If Bn is more than the salvage value, this means I will do check 1. I will use straight line to fix my trajectory here. If Bn is less than the salvage value, which is our case here, in that case, you will keep going with the declining balance. At some point, you just stop it. There is no switching to straight line. You just stop the depreciation at some point. So in our example here, let's calculate B5. So it's 500,000 times 1 minus P to the power 5. So I see here is 38,880, which is less than my salvage value of 100,000. So now I know which case I'm dealing with. So it's the second case of, or second check here, application is very, very simple compared to the first one. So I will calculate here the depreciation and the book value of every year following the declining balance formulas, which similar to what we did before in the previous example. So you just apply the formulas here of dt and bt, and I keep calculating bt, dt, and paying attention to my book value here, making sure that I'm above 100,000 salvage value, and that's the case for the first 3 years until the fourth year. I see here I'm dropping below 100,000, which is not acceptable. So I have to correct things right away here. So I will stop depreciation following the declining balance. And I will set my book value of 4 to be equal to the salvage value, which means that I will lose some value of the asset, but not following the declining balance, but I will here manually calculate it to be the difference between 108 and 100,000. All right, and then the fifth year, I have no depreciation and the book value stays the same to be equal to the salvage value. So it's much simpler, right? Much simpler. Applying this case check 2 to the second case of depreciation for declining balance method. Much simpler than using the first check, because the first check is something that you have to calculate two values, the DSLN, compare it to the declining balance. Every year you do that, but in the second case here, we're just paying attention to the book value in every year, making sure we're not dropping below the salvage value. All right, that's the end of it. Thanks for watching. Take care of yourself and those around you. Have a good day.